Welcome everyone. In this video lecture, we will solve a question on rectifier circuit which is from the Microelectronics circuits book. So the question is consider a half-wave rectifier circuit. So there is a half-wave rectifier circuit with a triangular input waveform with 5 volt peak to peak amplitude. Okay. So triangular waveform, input waveform 5 volt peak to peak. So the first peak is 2.5 volt and lower peak is minus 2.4. So it is 5 volt peak to peak, and the period of the signal is, say I am saying T, okay, capital T, and the middle T by 2, okay, and the R value is 1 kilo ohm. So assume that the diode can be represented by a constant voltage drop model. So the VD of the diode is 0.7 volt. So we have to find the average value of the V naught. So in such question, first of all, we have to find the output waveform, then we will find the average value of output voltage. Okay, so here in the question, it is already given constant constant voltage drop model. Okay, means if this one is a diode, so the diode is conduct only when this one will be 0.7 volt. Okay, means the cut-in voltage for this diode is 0.7 volt. So in such situation, the diode will only conduct because this one is a anode in connected to the supply. So diode will conduct when the Vi is greater than 0. Vi is when Vi is greater than Vd, diode conducts. Okay, diode conduct. This can be also also gives the information that after what time diode will be on and off. So there is a concept also called the transition voltage. In my rectifier video, I have already mentioned means how to solve the problem. For such situation, what we have to do for the transition voltage determination, what we have to do, we have to make the diode just on, we can say just on, and the current in the circuit or even in R circuit or R in the resistance will be 0. Okay, so the new modified circuit, first I am just telling means how to find the transition state where the diode is on and off. So what we will do, this should be simply our 0.7 volt. Okay, resistance will be same as it is. Okay, okay, we are, then this current I will be 0 and say this one Vi. So if we apply Kirchhoff's voltage law in this loop, one can write Vi minus 0.7 minus 0, because this one I 0, so V naught will be also 0. So this one is simply 0. So Vi equals to 0.7 volt. So this Vi equals to 0.7 volt, we have to plot in the this input waveform that will give the means state where the diode is on and off. Okay, so this point, that is our, in every rectifier problem, if some constant voltage drop model or some biasing is given, so we have to first find out the transition voltage, then we have to plot this equation Vi equals to 0.7 volt. So now after that we can decide whether diode is on or off. So simply the very simple thing is that if this one is the line, above this line, above this line, above this line, when Vi is greater than 0.7 volt, okay, any voltage like 2 volt, 1 volt, anything. So this will be diode will be in the on. Okay, diode will be, so D on I am writing here. Okay, and below this line means when Vi is less than 0.7 volt, any voltage, say 0 volt, so this value will be 0 volt, so this one is negative. So if we can say this one is an ideal diode, so this one is a reverse bias. Okay, so below this line means Vi equals to 0.7, diode will be in the off state. So it is very important to know this one. If this one is a ideal diode, so Vi equals to 0, align on the x-axis. Then above this one, above Vi equals to 0, diode will be on, diode will be off below the line. So but here we have to find this one. In my rectifier video, I have already solved a number of problems. So how to find this? Okay, so now we have calculated. Okay, so diode is on when the diode is on, okay, what should be the output voltage? So when diode is on, okay, when diode is on, okay, output voltage can be simply, we can write means say KVL in say loop 2. Okay, now we have to consider the V naught. So what we can write, Vi plus Vi, we can write minus Vd minus V naught equals to 0. So the V naught equals to Vi minus Vd. Okay. So we can find the output peak. Output peak. So we can say the V naught peak will be Vi. So Vi maximum in the positive of 2.5 minus 0.7. Very simple thing is that this should be 2.5 volt and minus 0.7. So it will give the peak, okay, of the output waveform, that is our 1.8 volt. Okay, so we can easily draw the output. Okay, and if we want to draw the output waveform, say I am just writing here, this point is say T1 and this point is T2, and in the middle, it is say simply our T by 4 point will be there. T by 2 is the this point, so middle, T by 4 just half. So now the output means at point T1, at this point, when Vi is same as that of Vd at T1. Okay, at T equals to T1, the Vi value is same as that of 0.7 volt. Okay, so at that time V naught will be Vi minus Vd. So Vi is also 0.7, 0.7. So it will be 0 volt. At T equals to T2, Vi is again 0.7 volt. Once again, I am showing you because at T equals to T, this point is also 0.7. So again, V naught will be Vi minus Vd. It is very simple, 0.7 minus 0.7. I am writing one step, each step I am writing 0 volt. So here the curve will be somehow start from and below this point when the diode is off. When the diode is off, okay, open circuited, V naught will be simply 0 volt. I am not going for any because this one is open, so I will be 0, V will be 0 when diode off. Okay, is it okay, clear? So now for this point, diode will be off and output value will be 0 volt. Now after that, it will go maximum at T by 4 and it should be our like this. Is it clear? Clear? And then after again it will go like this. Okay, it will go like this. So this one is the output waveform. Okay, output waveform, very simple. And this point This point is our 1.8 volt. 1.8 volt because V naught equals to Vi minus Vd. So Vi peak will be 2.5 and 0.7 we have to minus. So this one is the output voltage. So now we have already find the output waveform. Now we have to find the average value of the voltage output. So this part is clear somehow, output waveform. Now I'm just going to find the output, average output one. Okay, so once again I'm just repeating. First we have plotted the line, okay, transition line, that is this one. Vi equals to 0.7 volt. Okay, it is this one. This one is the time axis. Okay, then after we have plotted everything, so now I'm saying we have to find this point, say t1 and t2 will be these 2 points. Okay, so that point we have to find, and the output waveform at the middle, that is our t by 4. Okay, once again I'm doing this. Okay, so what we can do, this one is the output waveform. Okay, and here also it is 0. Very simple thing is that if you practice. Okay, so now what we have to do, okay, if this triangular wave, this one, this line is there, I'm just taking the same, only this portion. Okay, means up to, say this point is t by 4 and t, and so this point will be 0 0. Okay, okay, and this point will be t by 4 into 2.5. This point will be t by 4 into 2.5. So we can find this equation. This is nothing but simply a line equation, and 0.7. Okay, I'm just considering this one. So we can find the intersection point. Okay, what should be the T1? Clear? Because 2 points are given, x1 and y1. Say this point, and another point is this one is x2, y2. For the time being, I am saying this one is x-axis, and I am saying this one is a y-axis. Okay, so 2 points are given, x1, y1 and x2, y2. So line equation you can write y minus y1 by y1 minus y2 and x minus x1 by x1 minus x2. This was the line equation. So if we find this line equation, and this equation is already known, so we can easily find the intersection point. So first I am finding this line equation. This line equation. Okay. What is the equation of this line? Equation of line we have to find. So for this purpose, what we can say, 2 points are given. Okay, because if we find the points, okay, this point, so area we will easily find. Okay, how we will discuss after 5 minutes. So 2 points are given, 0 0, and another point is t by 4 and 2.5. Okay, okay, a line passes through the origin, so there must be y equals to mx kind of thing. So m slope we can find. We can also find the slope directly. Okay, that point also I will show, but now we are just using this formula. So I'm just writing y minus y1, say 0, then 0, y minus y1, 0 minus 2.5. Okay, clear? X minus x1, x1 minus. So one can write 4x by minus t. Okay, or y equals to minus 10x by minus t. So 10x by t. Okay, I have written in terms of y, but okay, so your y is your vertical axis is nothing but simply vi. So y is nothing but simply vi, 10 x is our t by t. So this one is the equation, 10t this equation of line will be 10 t by t. That is our vi. Okay, vi equals to 10 t by t. So if you find this point at t by 4, okay, now we can at t equals to t by 4, the Vy value will be 10 into t by 4 into this t. Okay, t cancel 2.5. So we are in the right direction. So this equation is clear. You can also find this very simple mathematics kind of thing, because y equals to mx. This slope we can easily find. Okay, this slope we can easily find, means this height by this. Okay, it will give the slope. Okay, this slope means this slope will be 2.5 by t by 4. Okay, this 10 theta, that is our 10 theta, this height. So this height will be simply 2.5, and this should be our t by 4. T by 4 means 10 by t. Okay, 10 by t. So this one is nothing but simply m. So m is 10 by t, x is our t, y is our vi. So like that also you can find. So now we have already find this equation. So now this equation we know, the equation vi equals to 10 t by t. And now one more line is there, means the same thing I am doing here. Okay, or we can make it with like, okay, this one is line and this point is our Vi equals to 0.7 volt. Okay, so this point we can say T1 point. So T1 point can be find like 10 T1 by T equals to 0.7. Okay, so T1 can be 0.7 by 10 into T, or 0.07, 0.07 into T. So T1 point is clear. This T1 point is now we have calculated. Why we are doing? We will tell later, because we have to find this area for the average value. Okay, so if we know this T1 point, even if we don't know the T2, we can find this area and double it, then it will come. Okay, so T1 is now known to us. Okay, in addition to that, what we will do now, average value, average value. So V naught average we have to find. So for V naught average, what we can say, the period of the waveform. Okay, for 1 by t. Okay, then after what we can write, from here we can say t1 to t2, t1 to t2, the area of this region. Okay, area in the yellow region we have to find. Okay, clear na? So this area we have to find. Okay, so what we will do, one can easily write 1 by t into 2 times, if we find this area, and if we double it, if we double it, okay, then it will give the entire area. Okay, 2. So now this one is some kind of right rectangle. Okay, so if height base is there, so area half into bh. Okay, so one can write simply 1 by 2 b. B, that is our this height. Okay, b by h. So h is how much? This point is our 1.8 volt. Okay, so write it 1.8. Okay, h is 1.8. So now b, so this point is t by 4 and this point is t1. So this one will be t by 4 minus t1. Okay, and we have already multiplied with 2 to make it double. Okay, so what we can do, these two cancel out. 1 by 2 into 1.8, t by 4 means 0.25 t, minus t1 already calculated 0.07 t. Okay, t1, because no need to find the t2 also you can find, but I have just find out only t1 and just double the area for the average value calculation. So then after, what we will do, 1 by t into 1.8 the height, okay, into this one, 0.25 t into 0.07, so it will come nearly 0.18. Okay, with t, so this t and this t will be cancel out. Okay, so if we multiply 1.8 into 0.18, it will come 0.324 volt. So our v naught voltage will be simply 0.25 0.324 volt. So we can easily find this area, because first find we have find this area and try to double it and go with 1 by t time period. This t2 point also we can calculate. Okay, this t2 point also, so this point is clear. So this is the question, uh, and this is the solution. So for T2 point, I am just giving a hint. One line is there. This one is 0.7 volt. Okay. So this one is 0.7. So we have to find the T2 point. So we can also find this. Okay. Means the one point will be what? T by 4, 2.5, and where it is, the another point is cutting it, say T by 2 or 0. Okay, means simply this point is our t by 4. Okay, t by 4 point, x-axis point, and this one is 2.5, and this point is our t by 2, and y-axis is 0. Okay, so this one is also two line equation, 2 points are there. So if we go for this formula, we can also find the vi, this line equation, the vi equals to 5 minus 10 t by t. Okay, this one is the equation, this line equation. So you can also find t1 t2, so you can also find this area plus this area, so this will be symmetrical. So I just double it, and we have find the average output value of the current. Okay, the output waveform is clear, because this is very simple. Okay, but you have to go from this transition voltage concept, where we have to make the line, then above this diode is on, and below this diode will be off. Okay, so this is all about this question. So thank you for watching this video.